Hello everyone. I know it's been a long time since I've made a video or discussed anything about any of the projects that are happening at the moment, but I'm about a day away from finding out if this latest version is the winner for VR and Pointclouds. Also, on a more positive note, we've hit 200 subscribers, and that's really cool. I'm very happy that anyone's even interested in what I'm doing. It's really cool. Right now, this is version 11 of the Pointcloud engine. Now, I know it doesn't look like much right now, but essentially what's happening is in this scene right here, we have a converter that converts the point cloud into cubes of 1 meter, and then I do a capture on each cube, and I store reference positions for each index. I'll reference index for each position in the point cloud, so it's all loaded into memory at the moment. And basically, what happens is as the camera moves every 1 meter, or from cube to cube, basically, it'll create a buffer based on the capture data. So essentially, if you have a look, actually, I'll just show you. It's a bit easier to see rather than explain. Okay, so this is it from the editor. If I grab the camera and move it out, you can see the points reduce. These are pre-captured, not positions or colors, just indexes of indexes in the original point cloud. So basically, what it's done is a capture from an octant, like a quarter of a cube, basically, or an eighth of a cube, depending on the camera angle and position, and basically just only shows or will draw the points that actually will matter to the scene. Right now, this is the actual full. I'm not at the stage yet where it's displaying the whole thing, but they are all loaded and everything's working fine. But this cloud has about 9 million points in total, but in this one cube it's only about 1 million or so. And what I'm planning to do is, within a 2 meter radius, we're going to show the original point cloud. And what I'll do is I'll thicken it up by, like the original plan, with 64 points per millimeter. And as you zoom out, that isn't necessary, but for up close, it is necessary to fill in all the hole, like not fill in the holes, but fill in the spaces. There is backface culling, but backface culling is also not that intense, because even in the capture, it was captured with backface culling, so it's not really that much of a strain on the system. What happens is, as the point cloud is loaded into an octree of about 8 meter cubes, and then inserted into that. This basically, the only reason that happens is so you can do frustum culling. So basically, each cell in the octree is about 8 cubic meters, 8 by 8 by 8, and inserted into that is the 1 meter cubes of the point cloud. This is just for backface culling, and then basically what we're doing is checking the quadrant or octant the camera is in relative to the cell, and then it will only access the indexes that, from this level of detail, so basically, you'll end up with a buffer that basically you'll need two buffers, they swap each other, as you're moving, and so you have your at the moment. What's happening is it's all in memory. You've got your captures for each hemisphere of the cell, and so basically it's just really just streaming in indexes. So basically, what I'm going to do after this is see once it's in memory, we'll have for sure unlimited detail in VR, but based on the limit of your memory, basically, because this point cloud, 9 million points, but so you're only going to get like a few different unique point clouds. But instancing could take up the entire, however 8 kilometers if you want to, whatever. It shouldn't be a problem. But we'll see that officially tomorrow, and the same will be true. But it's basically just memory limit at the moment. But what I'll do, because they're actually stored in memory mapped files, I will see how fast it is to actually only put the index memory into data. Index data into memory, and then see what we can do as far as streaming off the hard drive. I'm pretty sure if you're going to do it every frame, you're not going to get more than 30 frames a second, because once you go up to a resolution of like 1920 by 1080, I remember last time I did a test with memory mapped files, I could only grab that many pixels, about 30 frames a second. So if maybe with a staggered approach or a coroutine, maybe it wouldn't be so intense, or only updating new data. I might have to work on that. Anyway, I just wanted to let you guys know. I know it's a bit of a scattered video, and I'm very tired. But it has been a while. But I've been having to do a lot of work lately, and haven't had a lot of free time. I am planning, if tomorrow's test works, I'm going to create a open beta that people can, well, not a free open beta, but next week I plan to sort of release a paid beta, so that people who want to use it as it's being developed, assuming it works, theoretically it seems to be fine. The main thing is it fine for VR, and that's basically the main point. If it isn't, it'll still be great, because you'll still be able to obviously view point clouds, but the main goal was to have it visible in virtual reality, and so it doesn't look like much, and I'm pretty sure I didn't explain it really well or clearly, but I just wanted to share this with you tonight, and I'll have another video tomorrow when hopefully I've covered at least a kilometer with this point cloud, so we'll see what happens. Anyway, thanks very much for your interest, and thank you to everyone who has supported so far. You made a real difference, kept the electricity on, and I'm mainly hoping with the paid open beta to provide enough of resources and time for myself to not only complete this project, but to actually not create multiple file formats as well, because basically, I need time to do that, and there's a lot of point cloud formats, and PCD hasn't been suitable for everybody from what I've heard, but obviously if you have your own format, you could obviously replace the code, but I'd like to make it easier and be a complete project without anyone having to screw around or do anything. So anyway, between this and screen space displacement mapping, they're the only two projects that are seeming to have any real interest. And anyway, I'm talking too much. Thanks for listening. Have a great day, and I'll see you tomorrow.